Hi friends, now I am going to talk about VA and switching characteristics of a silicon control rectifier SCR. Before going to talk about VA and switching characteristics of SCR, first let me introduce about basics of SCR. Introduction about basics of SCR. The SCR is a three-terminal semiconductor switching device. Most important element after diodes and transistors. These SCR were introduced in 1957. This is used to perform many functions like rectification, inversion, and regulation of power flow. It has different names in organs such as thyristor, transistors, etc. etc. It is a unidirectional power switch. Next, we are going to see about the construction of SCR. SCR combines the features of rectifier and transistors. The rectifier, which performs the uh, conversion of AC to DC voltage or current, etc. When PN junction is added to a junction transistor, resulting 3 PN junction device is called SCR. SCR has three junction device. The combination of rectifier and junction transistor to form PN device. This forms SCR. Three terminals are taken, which are outer P-type material called anode, outer N-type material called cathode, and the base of the transistor section called gate G. The gate, cathode, anode correspond to grid, plate, and cathode of thyratron. SCR is also called thyristor. SCR can be used to control the electronic switch, which can be turned on or off electronically. Thyristors have low on-state conduction losses and higher power handling capabilities. Next, we are going to see about the working. Um, First, let me tell you about the basics of SCR. The SCR conducts only based upon the gate signal. According to working, when gate is open, that is no voltage is applied to the gate. Under this condition, the junction 2 is reverse bias and junction 1 and junction 3 are forward bias. Hence, in this situation, junction 1 and 3 are just in NPN transistor with the base open. No current goes through the load. Therefore, ACR is being cut off. However, voltage is increased. That is when we increase the voltage, J2 breaks down. Now ACR conducts heavily. It is an on state. The applied voltage is breakover voltage. When gate is given positive voltage with respect to cathode, ACR conducts heavily at small applied voltage. That is the small gate voltage is necessary to conduct heavily. In this situation, J3 is forward bias and J2 is reverse bias. The electrons from N type move towards left and the holes from the uh, P type moves towards right. This fusion makes J2 anode current increases. This makes more electron available in J2. Therefore, J2 junction breaks down. ACR conducts heavily. Once ACR conducts, the gate loses all control. Even if gate is removed, anode current does not decrease at all. Only way to reduce the conduction is to reduce applied voltage to zero. Then we are going to see about the conclusions from the working of SCR. SCR can be act only like a switch. That is why it has been on state or off state. There is no state in between. There are two ways to turn on SCR. First method uh, is to keep gate open and make supply voltage equal to breakover voltage. The second method is to operate SCR with supply voltage less than the breakover voltage and turn it on by means of small voltage applied to the gate. The applying small positive voltage to the gate is normal way to close an ACR because breaker voltage is usually much greater than supply voltage. To open ACR, they reduce supply voltage to zero. There is no other go. Then we are going to see about the VA characteristics of ACR. It is the curve between anode cathode voltage and anode current of ACR constant gate current. It has two, that is forward characteristics and reverse characteristics. Then first let me tell about the forward characteristics. When anode is positive with respect to cathode, the curve between P and I is called forward characteristics. In figure, just a minute. In figure OABC, it lists the forward characteristics of VA forward characteristics. That is SCR at Ig equal to 0. If supply voltage is increased, the point A is reached. When SCR starts conducting, under this condition, voltage drops suddenly. Most voltage appears across RL, that is load. If proper gate is made to flow, SCR can flow at much smaller supply voltage. Then we are going to see about reverse characteristics. When anode is negative with respect to cathode, the curve between B and I is known as reverse characteristics. The reverse voltage does come across the ACR when it is operated with the AC supply. If the reverse voltage is gradually increased at the first time, the anode current remains small, and at some reverse voltage, avalanche breaker occurs, and ACR starts conducting heavily in the reverse direction, as shown in the curve DE. The maximum reverse voltage at which the ACR starts conducting heavily is known as reverse breakdown voltage. Then we are going to see about switching characteristics of ACR. It has two mechanisms: ACR turn-off mechanism and ACR turn-on mechanism. First, let me talk about ACR turn-off mechanism. Turning off one ACR means bringing the ACR from conducting state to blocking state. To turn off an ACR, two things are to be done. That is, reduce the anode current below its holding current level, and next one is application of reverse voltage. When the anode current is zero, if you apply forward voltage to ACR, the device will not be able to block this forward voltage due to the fact that excess charge carriers are still at the junctions. So the device will start conducting even when the gate signal is not applied. In order to avoid this, the reverse biasing of ACR is done to remove the excess charge carriers from all four layers. The turn-off time is defined as the time from the instant anode current becomes zero to the instant ACR reaches its forward blocking ability. The turn-off time is T off equal to TRR plus TGR. TRR, which means reverse recovery time, and TGR means gate recovery time. Let me tell about the ACR turn-on mechanism. When positive gate signal is applied to the forward biased ACR, the transition of ACR from blocking state to conducting state is called a turn-on mechanism. The time taken for ACR to traverse from blocking state to conducting state is called the turn-on time. The turn-on time is divided into three periods. That is, it is divided into TD, TR, and TP. That is T on equal to TD plus TR plus TP. TD equal to delay time, TP or TS equal to peak time or spread time. Time taken for anode current to reach 0.1, that is IA, is called delay time. The time taken by anode current to increases from 0.1 IA to 0.9 IA is called rise time. The peak time is the time taken by anode current to rise from 90% to 100% of its full value. That is 0.9 IA to maximum of value of IA. This graph explains the 0.9 IA to 0.1 IA. This graph explains the turn on and off mechanisms. Then we have quiz questions at last. These quiz questions. Fabricated layers of SCR are, the answer is D, either A or B. NP, NB or PN, PN. The next, the holding current of the thyristor is more than latching current, always more than latching current. Then next, anode current is in a thyristor is made up of electrons or holes. Either it can be electrons or holes. For normal ACRs, switching turn on depends on a gate current. A thyristor, when triggered, will change from forward blocking state to conduction state if its anode to cathode voltage is equal to peak working of state reverse voltage. Thank you for your attention.